let's look at a problem. A particle moves along a straight line such that its position is defined by s, which is a function of t, is equal to t squared minus 6t plus 5 in meters. Determine the average velocity, the average speed, and the acceleration of the particle when t is equal to 6. Important to note here is we need the average velocity and the average speed. It's not the instantaneous velocity. The difference between velocity and speed is that velocity is a vector, so there we care about direction, where speed is just distance covered divided by the time in which that distance has been covered. It does not care about direction. So let's look at how we would solve this problem. First of all, for finding the average velocity. Now, because it's average, we can take the position where this particle started off, and we can look at the position where it is at t is equal to 6 seconds, and we can get the displacement, and we can divide that by 6 seconds, which is the time that has passed, to get the average velocity. So in that period, it might have moved faster, might have moved slower, but the average velocity is what we're interested in. So at the top of the slide in green, I've written just again to remind us the equation that we were given for the position. So let us examine how this particle moves. So when time is 0, if you plug that into the position equation, you see that the particle is at 5 meters. If time moves on by 1 second, t is 1, and you plug that in the position, you see the particle has moved to the left to 0 meters. And so you can test for time equals 2 seconds, 3 seconds, 4 seconds, 5 seconds, and then at t is equal to 6, the particle is again at 5 meters if you plug t equals to 6 in the position equation. So from start to t is equal to 6, the particle has moved around, but it is again at the position where it has started. So the average velocity will be 0, because it would be the displacement divided by the time. The displacement is 0 because it started at 5 meters, moved around, and then ended at 5 meters. So it in effect did not change position in that period of 6 seconds. So v is delta s over delta t, which would be 0 divided by 6, and so the average velocity is 0 meters per second. Now the average speed is the total distance that it has traveled in that time, the particle, divided by the time. So now we need to figure out what is the path that this particle has traveled along, and we need to, even though it ends at the same position where it started, we need to take into account the path that it has taken. And we need to take that distance and divide it by the time, and then we get the average speed. So at time 0, the particle is at 5 meters. Now we know that the particle moves around on a straight line. And we know at t is equal to 6, it's back at 5 meters. So somewhere it must have turned around. It must have, let's say, moved to the right and then turned around and came back to end at 5 meters again. So where is that position where it turned around? At which time step did the particle turn around? And we can find that by setting the instantaneous velocity equal to 0, because at that point where it turns around, the velocity will be 0 for a small instance of time. And so we know v is ds dt. So we take the time derivative of the position, so that time derivative would be 2t minus 6, and we set that to 0, and we solve for t, and then we get t is equal to 3. So at second number 3, the particle for a brief moment stops and turns around and goes back, because it is a 0 velocity at t is equal to 3. So we know it starts at 5 meters, then it moves for 3 seconds in one direction. We take that t is equal to 3 seconds, we plug it in to our position equation, and we see at t is equal to 3, it is at minus 4 meters. Then we know it turned around and it's moving back to 5 meters when t is equal to 6. So if you look at the right bottom part of this slide, you'll see it's at 5 meters, then it goes to minus 4 meters, then it goes to 5 meters again. So that total distance is 18 meters. From 5 meters to minus 4 meters, that's 9 meters traveled. And then again from minus 4 meters, that position, to 5 meters, that's another 9 meters. So the total distance that this particle has traveled is 18 meters in a time of 6 seconds. And so if we take 18 meters divided by 6, we get 3 meters per second. That is our average speed. The last question was to find the acceleration of this particle at t is equal to 6. Now note here that we are not asked to find the average acceleration. It's just the acceleration, so that is the instantaneous acceleration. So we can say a is equal to the time derivative of velocity. A is equal to dv dt. So we have the position equation. If we take the first time derivative of the position equation, we get velocity. And if we take another time derivative of velocity, we get acceleration. So let's first get the instantaneous velocity at t is equal to 6. V is ds dt. Taking the derivative, that gives you 2t minus 6. And taking another time derivative, the 6 is constant, so that is 0. And we are left then with a is dv dt, which is 2 meters per second squared. So that is the acceleration at time is 6 seconds. Now note that this question doesn't tell us anything about whether this particle has stopped moving at time is equal to 6 seconds. It might carry on. We don't know the total time frame. So it might still carry on, turn around again, come back, turn around again. That all depends on the equation for the position, and that equation, as we were given, is t squared minus 6t plus 5. So you can go and plot that equation, and then you can see how the position of this particle changes as a function of time.